Good afternoon, my dear students. So today in this sessions we are going to learn the first problem on the trusses. Okay, a 4-bar trusses element as shown in a figure. So in which we need to determine the following condition. The first of all, we need to find out the nodal displacement. So the nodal displacement nothing but we need to find out the value of q1, q2, q3 and q4 we need to find out. As well as in the second condition, we need to find out the stresses in the each element. So this means that we need to find out the sigma 1, sigma 2, sigma 3 as well as sigma 4 we need to find out. The third condition in which we need to find out the reaction at the support. Reaction at the support means we need to find out the value of R1, R2, R3 and R4 we need to find out. So in this problem, the area of element is given as 100 mm square as well as the modulus of elasticity or we can say as Young's modulus. It is given as 2 into 10 power of 5 Newton per mm square. Clear? So let us see total how many nodes we have. We have total 4 nodes. Let us see, this is the first node. It is a rigidly fixed. This is the second node. This is the third node and this one is the fourth node. And how many elements we have to observe in the figure. So let us see, if we are joining the first node to the second node, we are forming the first element. If we are joining the second node to the third node, we are forming the second element. If you are joining the third node to the first node, we are forming the third element. If you are joining the third node to the fourth node, we are forming the fourth element. Clear? So the distance between from the first node to the second node, how much will be there? 40 mm. How much dear? 40 mm. From second node to the third node, we have the distance is how much? 30 mm. The distance between from the second node to the third node, we have the length is 30 mm. Clear? So the distance between the third node to the fourth node, because this third node, fourth node should be parallel to the first and second node, it should be same. How much? The length from third node to the fourth node is 40 mm. How much? 40 mm. The distance from the fourth node to the first node is how much will be there? It should be 30 mm. It should be how much? 30 mm. Clear? So let us see. The first step, what we need to find out here. So observe here. So this element 1 fix between first node. The element 1 is lies in between first node as well as in the second node. The first one is rigidly fixed, or we can say as rigidly hinge support is acting at a point of 1, as well as at the node of 2 the roller support at a point of 2, or at a node of 2 we can say. Clear? Come to the element 2. Element 2 in which the pinned at a node 3 as well as the roller support at the node of 2. Clear? So come to the point of 3, element number 3. So element number 3, if you want to observe, they joining third node as well as first node, then only they forming of third element. Is it right? So the element 3 is, how's it the nature? It is a fix. Is it right? At a node of where? At a node of 1 and pinned at a node of 3. Clear? Or we can say as directly. So if element 1 is lies in between first and second, the first one is, how is it? It is the hinge support. The second one is the roller support. Come to the point of 2. Is it right? The element 2. So element 2 is lies in between second node and third node. The second node is the roller support and third node is the pinned. Okay, come to the point of element 3. Is it right? So element 3 in which the joining from third node to the first node, they are forming of third element. Is it right? So the third node is a pinned, okay, at a point of 3 and fixed at a point of 1. Come to the point of element number 4. So element number 4 is, how is it? If you are joining the third node to the fourth node, we are forming the element number 4. Is it right? So but the main thing is, it is a pinned at a point of 3 and fixed at a point of 4. Clear here? I hope so, no one is having a doubt. This is the first node and fourth node, it's a rigidly fixed. Is it right? At a point of 2, the roller support is acting. At a point of 3, it is a pinned is acting. Clear? At a point of 1, they having the two forces acting. The force F1 as well as force F2. The force F1 is acting in X direction. The force F2 is acting in a vertical direction. Come to the point of 2. At a point of node 2. So at node 2, again the two forces is acting. Which force? The force F3 as well as force F4 is acting. Clear? As well as here, come to the point here, because the tensile force is acting. How much tensile force is acting? 20 into 10 power of 3 Newton tensile force is acting toward the right side. So at that time, the nodal displacement also acting, Q3 as well as Q4 also acting here. Then come to the point here, the pin support. Here one compressive force is acting. How much compressive force? 25 into 10 power of 3 Newton compressive force is acting. Clear here? Then as well as the nodal displacement Q5 and Q6 is acting, as well as the nodal force is F5 as well as F6 is acting. Clear? Come to the point of node 4. So node 4 in which the nodal displacement Q7 and Q8 is acting, as well as the nodal force F7 and F8 is acting. Clear? Then observe here, the distance from the first node to the second node is how much is there? 40 mm we took here. And the distance between the second node to the third node, how much distance we took here? 30 mm. Then let us see. First of all, we need to find out the node data. How many nodes we have here? 1, 2, 3, 4. We have 1, 2, 3, 4. We have the 4 node. So in the X direction as well as in the Y direction. Come to the point of node 1, the X1 is 0, Y1 also 0, 0 comma 0. Come to the node 2. Okay, node 2 in which the X displacement from 0 to 1 to 2 is how much distance is there? 40 mm, 40. Y displacement is 0. So for that reason we can represent as 40 comma 0. Come to the node 3. Node 3 in which, so X is how much is there? From here to here is X. Total length is how much is there? X3 is 40 mm and this Y3, this height, vertical height is how much is there? 30 mm. 40 comma 30. X3 is 40 mm, Y3 is 30 mm. 40 comma 30. Come to the node 4. Node 4 in which, how is it here? So X is 0. Here X value is 0. But this vertical height value, vertical height how much is there? 30 mm. 0 comma 30. Clear? I hope so, no one is having the confusion here. So let us see. Okay. So again, second step, we need to find out the element connective table. We need to find out. First we have to write element number. How many element we have? Total we have the 4 element. First element, second element, third element, fourth element. Clear? First we have to write initial node, final node, initial node, final node. Is it right? How to write, that is the most important. Clear? First of all, we have to go for element number 1. Element number 1. Clear? The initial node is 1, final node is 2. Initial node is 1, final node is 2. So again element number 2 in which the initial node is 2 and final node is 3. If you want to join the second node to the third node, the forming of second element. Is it right? The initial is 2 and final is 3. Clear? Come to the node 3. So which one is the initial here? Initial is this one, 3, and final is 1. So that's what in the third one, in the third element, I am representing here the initial node is 3 and final node is 1. Clear? And come to the element number 4. Element number 4, if you want to join from the third node to the fourth node, the forming of element is fourth. So here the initial node is, which one is there? Initial node is 3 and the final node is 4. Clear? I hope so. No one is having the doubt. Let us see. So the initial node 1 and the initial node is 2. The distance is how much is there? 40 mm. Or we can say as the element length of the each element. If you consider the first element, the distance from the first initial node to the final node, how much distance is there? 40. Come to the element number 2. From second to third, distance of how much is there? 30. Clear? If you want to form the third element, the distance from the third node to the first node, we have the length is how much? It should be 50, 10 mm extra. Is it right? Then in the fourth element in which if you join the third node to the fourth node, total length from the third node to the fourth node, how much is there? 40 mm. Clear? I hope so. No one is having a doubt. After that, our main intention is we need to find out L and M. Then how to find L and M, I will tell you. Let us see. First of all, we need to find out for the element number 1. We need to find out the value of LE, L and M for the element number 1, and as well as same procedure we have to follow for this element number 2, element number 3, as well as for the element number 4. After that, we will get the value of L and M value. Is it right? First of all, we have to go for element number 1. For element number 1. So LE is equal to under root of, we have the formula is x2 minus x1 whole square plus y2 minus y1 whole square. Already we draw the derivations. Okay. So here x2 nothing but this final minus initial, final minus initial. So here, come to this point here. Okay, here x2 is how much is there here? Here x2 we have 40, x2 minus x1, 40 minus 0, y2 minus y1, 0 comma 0. Clear? 40 comma 0 whole square plus 0 comma 0 whole square. So for 40 whole square, if you remove this square and root, then you will get the 40 mm. Clear? After that, we need to find out the L value. Clear? L is equal to x final load minus x initial node by LE. So x final node nothing but x2 minus x1. So L also we call as cos theta. L is equal to cos theta. Already we draw the derivation. Is it right? So x final node nothing but x2, x initial nothing but x1 by LE. So here x2 is how much is that here? 40 minus 0 by 40. If you divide, then you will get the answer of L equal to 1 mm. Clear? Then come to the point M. Clear? M is equal to y final load minus y initial load by LE. So final load is how much is there? We have y2 minus y1. y2 is 0 comma 0, 0 comma 0 by LE value how much we got it here? 40. 0 by any number should be 0. So we got the answer is L equal to 1, M equal to 0. We need to substitute in this tabular column. L value is 1, M value is 0 in the first element. Again the same procedure we need to follow for the second element. Then how to find out the second element? The same concept you have to go for it. L is equal to under root of. Okay. Here we are joining which node here? If you want to form the second element, let us see. Second element, we need to join the initial node and final node. The initial node is 2, the final node is 3. Clear? That's what I am representing here. Second node and third node. So here Second node is 40 comma 0. So 40 comma 0 we can represent here x2 and this one is y2. And 40 comma 30 we are representing here x3 comma y3. Clear? So after that, final node minus initial node, nothing but x3 minus x2, x3 minus x2 whole square plus y3 minus y2, y3 minus y2 whole square. So x3 how much is there? 40 minus x3 minus x2 is how much? Again minus 40 whole square plus y3 minus y2. y3 is how much? 30 minus y2 is 0 whole square. So after that you will get the answer is L equal to 30 mm. Clear? I hope so you don't have the confusion. This should be cancelled. The remaining term should be 30 square. So if you cancel square and root, it will become as only 30 mm. After the getting the value of LE, again we need to find out the value of L. Again the same concept we need to follow here. This x3 minus x2, this x3 minus x2 by LE. x3 value is how much is there? 40 minus 40 by 30 equal to 0 by 30 equal to 0. L value we are getting as 0. Clear? I hope so no one is having a doubt. Again the same concept here we need to follow here. y3 minus y2, y3 minus y2 by LE. y3 is how much is that here? We have the value is y3 is 30 minus y2 value is 0 by 30. If you cancel the term then it will become as 1. So L is 0, M is 1. Clear? For element number 2 we got it. The L is 0, M is 1. L for the element number 2, L is 0, M is 1. Again for the same thing we need to find out for the element number 3. So if you want to find out for element number 3, so let us see how the element number 3 is forming. If you are joining the third node to the first node, we are forming the third element. If you are joining the third node to the first node, we are forming the third element. For that reason I incline in this way. Clear? 3 and first. So the first node we have the point is 0 comma 0, 0 comma 0 we can represent here x1 y1, and this 3 we can represent here how much we got here? 40 comma 30. So we can represent here x3 comma y3. Again we need to follow the same concept here. L is equal to x3 minus x1 whole square, x3 minus x1 whole square plus y3 minus y1 whole square. What is the formula here? x3 minus x1 whole square plus y3 minus y1 whole square. Here x3 is how much is that here? 40 is there. Clear? Minus x1 is how much? 0 whole square plus y3 is how much here? 30 minus y1 is how much? 0 whole square. So 40 square plus 30 square. 40 square nothing but 1600, 30 square nothing but 900. Is it right? If you add this one you will get 2500. So after that the root of 2500 is 50 whole square. Then this square and this root will cancel, then you will get the answer is 50 mm. Clear? So LE value we are getting the 50. After that, getting the value of LE, we need to find out the value of L. The L is x final node minus x initial node by LE. So x final node here, which one is the final? This is the final and this is the initial. So x1 minus x3 by LE. x1 is how much we got here. So here x1 same procedure we have to follow here. 0 minus 40, 0, x1 is 0 and x3 is 40. 0 minus 40 by 50. So if you cancel this term, then it will become as L is equal to minus 0.8. L value is minus 0.8. Again the same concept we need to follow for the M. So M also called as sin theta. M is equal to sin theta is equal to y final node minus y initial node by LE. So y final node is how much is that here? We have final node is y1 minus y3, y1 minus y3. y1 values how much is there? 0 minus y3 values how much is there? 30 by LE is how much is there? 50. 30 by 50 it become as minus 0.6. LE is equal to minus 0.8. ME is equal to minus 0.6. Clear? I hope so. No one is having a doubt. The same value we need to substitute in the tabular column. L is equal to minus 0.8. M is equal to minus 0.6. Again the same concept we need to follow for the element number 4. We need to find out the value of L and M. Clear? Come to for the element number 4. Element number 4 if you want to form, then we need to join the entities from third node to the fourth node, then only we are forming the element number 4. Is it right? So for that reason we have to use the formula is LE is equal to, here initial is which one is there? 3. Final is which one is there? 4. Clear? For first of all, final node x4 minus x3, x4 minus x3 whole square plus y4 minus y3, y4 minus y3 whole square. Clear? Then let us see, x4 is how much is there? X4 value is 0 minus x4 minus x3 is how much is there? 40. 0 minus 40 whole square plus here, so y4 is how much is there? 30 minus y4 minus y3, 30 minus 30, it should 30 minus 30 should be cancelled, the remaining should be minus 40 whole square. Then after that this power and root will be cancelled, then you will get the answer is L is equal to 40 mm. After getting the value of LE, then we need to find out the value of L and M. L is equal to x final node minus x initial node by LE. So x final node nothing but x4 minus x3, x4 minus x3 by LE. So x4 value is how much is there? 0 minus x3 value is how much is there? 40 by 40. Then if it is cancelled, it become as minus 1. Clear? L is equal to minus 1. Then after that we need to find out the value of M is equal to sin theta value we need to find out. So what is the formula is there? Y final node minus y initial node by LE. So here final node is how much is there? 30 minus 30, y4 minus y3, y4 minus y3, 30 minus 30 by LE value is how much we got here? 40 mm. So 0 by anything should be 0. So L equal to how much we got here? Minus 1, M equal to 0. We need to substitute in the table column. L is equal to minus 1, M equal to 0. We need to substitute in this tabular column. So after that what we need to find out? We need to find out the elemental stiffness matrix we need to find out. Already we draw these derivations in the last class. Okay. After that we need to use the elemental stiffness matrix. Clear? K is equal to AE by LE, L square. L square nothing but cos square theta we can say, and ML nothing but cos theta into sin theta we can say, minus L square nothing but minus cos square theta minus cos theta into sin theta, cos theta into sin theta. This is sin square theta minus cos theta into sin theta minus sin square theta minus cos square theta minus cos theta into sin theta, sin cos square theta cos theta into sin theta minus cos theta into sin theta minus sin square theta cos theta into sin theta as well as sin square theta. Clear here? I hope so. No one is having a doubt here. After that we need to find out for the element number 1. So actually how many elements we have here? We have the 4 element 1, element 2, element 3, element 4. The same concept we need to follow here. First of all we have to go for element number 1. K1 is equal to A1 E1 by L1. The same formula we have to put here. So let us always you need to remember here. First of all we have to go for element number 1 table above. Clear? For element number 1, so L value is how much is there? 1, M value is 0. How much? L value is 1, M equal to 0. I hope so. No one is having the dot. This L and M we need to substitute here in this equation. Clear? L is how much is there? 1 whole square. So m into l means nothing but 1 into 0 should be become as 0 minus l nothing but 1 square. 1 square nothing but should be 1 only. Clear? Done. Minus 1 into 0. It should be how much? It should be become as 0. The same value we need to substitute here. So 1 into 0 should be 0 and 0 square should be 0 minus 0 into 1 should be 0 minus 0 square should be 0. Clear? This is over. Come to the third row. Third row in which minus l square. L square nothing but 1 square nothing but 1 minus m into l nothing but 0 into 1 should be how much? 0. L square nothing but 1 square. 1 square is value 1 only and m into l means you need to multiply. 0 into 1 should be 0. Clear? Minus 0 into 1 should be 0 minus 0 square should be 0. 0 into 1 should be 0. 0 square should be 0. Clear? So for that reason, that's always you need to remember here. That is the most important concept here. So this one, first of all, if you divide this whole the value, it will become as 5 into 10 power of 5. The value will come in the bracket is 1 0 minus 1 0 0 0 0 minus 1 0 1 0 0 0 0. Clear? After that we need to multiply this value of 5 into 1. 5 ones are should be 5. 0 minus 5 0 0 0 0 0 here minus 5 0 5 0 0 here. Clear? After that remember, so we need to write down the node. First node, second node, third node, fourth node. In the row, in the column also the same thing you have to represent. First node, second node, third node, fourth node. Clear? So actually here in this concept, first and second, what we can say? We can say as node 1. Third and fourth, what we can say? Node second. Please remember, that is the most important. First and second, what I am telling here, first node to second node we can say as node 1. Third and fourth, what we can say here? Node 2. If we are joining the first node to the second node, first node to the second node, we are forming which element here? We are forming the first element. Already we are discussed. Is it right? If we are joining the first node to the second node, we are forming the first element. Clear? So because we are discussing about which element? For the first element. Clear? Then this is the node 1 and this is the node 2. The node 1 is the initial node, node 2 is the final node. This is the initial node and this is the final node. Clear? After that, the same concept we need to follow for the element number 2. For element number 2, we have the formula here, A2 E2 by L2. A2 E2 by L2. So A2 is common. A2 is how much? 100 into the modulus of elasticity or Young's modulus value is 2 into 10 power of 5. L2 value, how much we got here? The L2 we got as 30 mm. Is it right? The length from here. Clear? From second to third, how much we got here? 30 mm. The second element of it is length. Clear? After that, if you divide this whole the value, then you will get the value is 6.66 into 10 power of 5. It will be appear like this. Clear? After that, if you substitute L equal to 0, M equal to 1, so in this formula, then you will get this value. Clear? After getting this value, we need to multiply by 6.6 into 1 like this. Let us see. 6.6 into 0 should be become as 0 only. 6.6 into 1 should be 6.66. 6.66 into minus 1 should be minus 6.66. If you multiply by 0, it become as 0 only. So for that reason, there is no need to multiply to the 0. Is it right? Then 6.66 into minus 1 should be how much? Minus 6.66. 6.66 into 1, it should be how much? 6.66. After that, what I am doing here, so in this one, this 3 and 4, what we can say? We can say as the node second. if you want to join the second element, okay, second element, we need to join the second node to the third node. Clear? Second node to the third node. These 3 and 4, the same here, I am repeating here. 3 and 4, what we can say? We can say as node second. 5 and 6, 5 and 6, what we can say? We can say as node third. Clear? No confusion for this one. 3 and 4 we can say as node second. 5 and 6 we can say as node third. Why we are making in this way? Because if you want to form the element number 2, then you need to join the second node to the third node, then only you are forming the second element. Let us see here. If you are joining the second node to the third node, then only you will get the element number 2. Clear? For that reason, we are following this procedure. 3 and 4 node we can say as node number 2, and 5 and 6 point we can say as node number 3. 3 and 4 we can say as node number 2. 5 and 6 we can say as node number 3. Clear? The same thing we have to repeat for the element number 3 as well as for the element number 4. Clear? Which formula is there? AE by L3. So area of the third section is how much? 100 mm, and modulus of elasticity is how much? 2 into 10 power of 5. And the length of the third section, this is the inclined line. The inclined line of its length, how much is given here? 50 mm is given. So you need to substitute L is equal to minus 0.8 and M is equal to minus 0.6 in above value, L square ML. In this formula we need to substitute. If you substitute here, then it will become like this. This figure will appear. Okay dear? After that, if you divide 100 into 2 into 10 power of 5 by 50, then you will get 4 into 10 power of 5. After getting this value, just you need to multiply 4 into 0.64, you will get 2.56. 4 into 0.48, 1.92. 4 into minus 0.64 minus 2.56. 4 into minus 0.42 minus 1.92. So if you multiply by 4 to all the value, this figure will be appear, or this matrix will be appear. After that, remember that is the most important, because if you want to know about element number 3, if you want to find out the element number 3, then you need to join the which node? Node third to the node first. Node third to the, like this inclined line. Node third to the node first, then only you are forming the element number 3. So node 3 is the initial node and node 1 is the final node. Clear? Clear. After that, this 5 and 6, already I told you, 5 and 6 what we can say here? Node 3. Clear? And 1 and 2 what we can say here? 1 and 2 we can say as node 1. This 5 and 6 we can say as node 3. 1 and 2 we can say as node 1. I hope so no one is having the doubt. Again the same procedure we need to follow for the element number 4. For the element number 4 we have the formula is K4 is equal to AE by L4. So area how much is there? 100, not 1000 here, it should be 100 only. Clear? 100 into modulus of elasticity, how much is there? 2 into 10 power of 5 by length by L4, how much is there? 40 mm. So this we need to substitute this value L is equal to minus 1, M equal to 0 in above matrix, like L square ML. In this form we need to substitute. In this formula we need to substitute A4 E4 by L4, L square ML minus L square. In this matrix we need to substitute the value L equal to minus 1, M equal to 0 here. After that, if you divide this whole the value, it will become as 5 into 10 power of 5. This matrix same as it is, we have to keep as it is only. After that we need to multiply this 5 into 1. 5 into 1 should become as 5. Clear? 5 into minus 1 it become as minus 5. 5 into minus 1 it become as minus 5, and it should become as 5. Clear? After that, if you want to join the entities from the third node to the third node to the fourth node, then you are forming the element is 4th. Which element here? Element number 4th. This 5 and 6, what we can say? I told you here, 5 and 6 we can say as node number 3, clear? And 7 and 8 we can say as node number 8, sorry, node number 4. So 5 and 6 we can say as node number 3, and 7 and 8 we can say as node number 5. After the getting the elemental stiffness matrix, we need to find out the global stiffness matrix. So in the global stiffness matrix, we need to add all the elemental stiffness matrix. The elemental stiffness matrix. So global stiffness matrix, it is a product of K1 plus K2 plus K3 plus K4. K1 nothing but the elemental stiffness matrix for the first element, and K2 is represent that elemental stiffness matrix for the element for the 2, and K3 is represent the elemental stiffness matrix is K3, and K4 is represent that the elemental stiffness matrix K4. Clear? After that, first of all, you have to write in the systematic form. First you have to write down this node. First node, second, third, fourth, fifth, sixth, seventh, 8. Total how many nodes we got it here? This is up to 8. So for that reason you have to present first, second, third, fourth, fifth, sixth, seventh, 8. So in the row as well as in the column you have to represent. Clear here? I hope so. No one is having a doubt. After that, this first node and second node, what we can say here? We can say as point, we can say as node number 1. 3 and 4 we can say as node number 2. 5 and 6 we can say as node number 3. 7 and 8 we can say as node number 4. The same concept we need to follow above also. If you multiply 1 into 1, then you have to go for it above. 1 into 1 where it is there in the first element. 1 into 1, how much will you get? You will get the value of 5. Clear? 1 into 1 you will get the value of 5. Again you have to check it, 1 into 1 is there or not in anywhere. So again here also there, 1 into 1 is 2.56. Clear? 2.56. Clear dear? After that, 1 into 2, 1 into 2 where it is there? Let us go for it. Check in this matrix. So here 1 into 2 is, how much is there? 0. Okay, again you have to check it here, 1 into 2 is there or not. Okay, 1 into 2 here also there, 0 plus 1.92, 0 plus 1.92. Clear? It's the same concept. Again 1 into 3 you have to go for it. 1 into 3 where it is there? Clear? So 1 into 3 is how much we got here? Minus 5. Again you have to check it, 1 into 3 is there or not? 1 into 3 is not there here. Okay, here also not there. So 1 into 3 how much we got here? Only minus 5 we got it. Clear? Again the same concept you need to follow for the entire the matrix. Clear here? For just you have to multiply, check it, 1 to 1 where it is appearing in, it's appearing in K1 or K2 or K3 or K4. We have to check it. Is it right? After that you need to put this value. After that, in the step number 5, we need to find out the equilibrium equation for the continuum. So the KQ equal to F. K nothing but we know very well the global stiffness matrix. What we can say here? Global stiffness matrix. And Q nothing but the nodal displacement. And F nothing but the nodal force. Clear? So global stiffness matrix value, how much is there? The entire value we have to present here. Clear? And Q nothing but we have to present here Q1, Q2, Q3, Q4, Q5, Q6, Q7, and we have Q8. The Q is indicate that the nodal displacement. What they indicate here? The nodal displacement. Okay, and F is indicate that the nodal force. Okay, F1, F2, F3, F4, F5, F6, F7, and F8. Then we know very well here, because at the node 1 the hinge support is there or fixed support also there. For that reason here hinge support, here hinge support. At the node 2 which support is there? The roller support will be there. Is it right? For that reason, this Q1 is 0. That's what we need to eliminate, this Q1 value as well as Q1 and this first column as well as second row, second column we need to cancel. Come to the node 2. Come to the node 2. Here the horizontal force at the node 1, the horizontal forces as well as the vertical forces is acting. So for that reason, Q1 and Q2 just we need to eliminate. This Q1 and Q2 we need to eliminate in the row as well as in the column. Clear? Can come to the point node 2. Node 2 in which force is acting? In the vertical forces, only one force is acting here. Clear? So okay, the roller support. For that reason, Q4 is become as, which one is that? Q4 is become as 0. Clear? Done. At the node, which one? At the node 4, it's one top of the hinge support. If it is a hinge support, will be there this horizontal forces as well as the vertical forces. Okay, it become as 0. We can say as Q7 as well as this Q8 become as 0. This Q7, this row, Q7 row and Q7 column we need to cancel, eliminate, as well as Q8 row as well as Q column we need to eliminate. Clear, dear? I hope so. No one is having the dot up to here. Clear? After that, which terms we have to consider here? Let us see which terms is not cancelled in the horizontal direction. So we know very well this 3, 5 and 6, this horizontal it will not be cancelled because we have to go for this F3 and F5 and F6 value. F3 in which we have to go for this 5 here. Again in the F3 we are getting this 5 value and F5 we are getting this 0. Again in the F6 we are getting 0, 5, 0, 0. Clear? Again come to this point here, F5 value or Q5 value we can say that. So here 0, again in the 5 7.56, again here 1.92. Already a mark here above. Is it right? It should be very useful for you guys. Again you have to go for F6 value because F6 is the horizontal, which one force? The vertical force is acting at the pinned. Clear? F6 how much? This type of the force is acting on the body. Compressive force is acting. If the compressive force is acting on a body, for that reason we need to consider the value of minus 25 into 10 power of 3 Newton. Clear? So here 0, 1.92, 8.11, 0, 1.92, 8.11. So after that we can represent here which one is horizontal. We are not cancel the horizontal one. We are not cancel is the only Q3 may not cancel, Q5 not cancel and Q6 also not cancel. Just we need to represent the nodal displacement Q3, Q5, Q6 and the nodal forces F3. Same procedure we have to follow. F3, F5, F6. F3 value is 20 into 10 power of 3 and F5 value is 0 and F6 value is minus 25 into 10 power of 3. Clear? After that, just we need to multiply these terms. 5 into Q3, 5 into Q3 plus 0 into Q5, it become as 0, 0 into Q6, it become as 0 equal to 20 into 10 power of 3. So after that, if you divide this value, then you will get the answer of Q3 is how much? 4 into 10 power of minus 2 meter. Again, if you multiply this term, then it become as Q3 value is 0.04 mm. This is we got the value of Q3. Again the same concept we need to follow here for the Q5 as well as for the Q6. This 10 power of 5 as it is 0 into Q3 it become as 0 plus here 7.56 into Q5, 7.56 into Q5 plus 1.92 into Q6 equal to 0. Again I will repeat here. 10 power of 5, 0 into Q3, 0 into Q3 should become as 0 plus 7.56 into Q5 plus 1.92 into Q6. Center point is 0. After that we have to repeat for the third row this first column. 10 power of 5 as it is, 0 into Q3 become as 0 plus 1.92 into Q5 plus 8.11 into Q6 equal to minus 25 into 10 power of 3. Clear? After that, so you need to consider above equation in this form 7. So if you divide this 10 power of 5 by 0, it becomes as 0. The same value we have to represent here, 7.56 plus 1.92 Q6 equal to 0, and here 1.92 plus 8.11 Q6 is equal to how much? If you divide this value minus 25 into 10 power of 3 by 10 power of 5, then you will get the answer is minus 0.25. Then how to multiply, that is the most important. Always remember, just you have to take the first value, just cross multiply here. This first value 1.92 multiply with above value, and this above value 7.65 you want to multiply bottom. Clear? If you multiply with 1.92 into 7.65, it becomes as 14.688 plus if you multiply 1.92 into 1.92, 3.686 Q6 equal to 0. Again you have to multiply 7.65 into 1.92, it becomes as 14.688 Q5 plus again if you need to multiply 7.65 into 8.11 Q6 equal to, if you multiply 0.25 into 7.65, it becomes as 1.9125. Clear? So our intention is we need to cancel the terms. Is it right? For that reason here positive terms will be there. So make as the, instead of positive we have to make as negative. So here instead of positive we have to make as negative. Instead of negative we have to make as positive. So for that reason, because here above is positive, below is negative, for that reason we need to cancel this above value. Again is 3.686 minus 62.042 become as minus 58.35 Q6 equal to 1.9125. If you divide the value 1.9125 divided by minus 58.356, then you will get the answer is Q6 is minus 0.03277 mm. Clear? If it is moved toward, so after the getting the value of Q6, you need to substitute in the above equation, or we can say as equation number 1. This is equation number 1. Okay, same 14.688 Q5 plus 3.686 Q6 equal to 0. So 14.688 Q5, these positive terms move toward the right hand side of the right hand side, it become as minus 3.686 Q6. Clear? Q5 equal to, so Q6 value how much we got here? We got the answer is 0.3277. You need to substitute here. Again you need to divide this value. If you multiply minus into minus plus 3.686 into 0.03277, you will be get 0.1208 divided by 14.688. If you divide the whole the value, then you will get the answer is Q5 is equal to 0.00822 mm. Clear? After getting the value of Q5 and Q3 as well as Q6, clear? After that, because we know the value of Q1, Q2, Q3 is already we cancel. Is it right? Q1 is 0, Q2 also 0, Q4 also 0, Q7 also 0, Q8 also 0. We got the value of Q3 is 0.04 mm and we got the answer is Q6 is minus 0.03277 mm, and Q4 value we got it as 0.00822 mm. After the getting the value of Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8 After that we need to find out the value of stresses in the each element we need to find out. So this question is carrying for the 15 marks, remember here. After that, step number 7, in which we need to find out the stresses in the each element. We have the formula sigma is equal to modulus of elasticity by length of the element minus L minus M, L, M, and the nodal displacement. This minus L is indicate that minus cos theta, minus M is indicate that minus sin theta, cos theta into sin theta, and Q is indicate that the nodal displacement. Is it right? How many nodal displacement we have? We have the 4 nodal displacement, Q1, Q2, Q3, and Q4 we have. Clear? And E by L1 minus L minus M, L, and M. Clear? Q1, Q2, Q3, Q4. First of all, we need to find out for the element number 1. If you want to find out for the element number 1, so we have to select the nodal displacement is Q1, Q2, Q3, and Q4. The node 1 and node 2 in which the element 1 is lies. If you joining the first node or second node, the forming of first element. Clear? Done. E, the modulus of elasticity already is given as 2 into 10 power of 5. The length of the element is given as 40. This is L is minus 1. M value already we got from the table 0, 1, comma 0. Q1 value is 0, Q2 also 0, and Q3 we got as a 0.04, and Q4 also 0. After that, if you divide this whole the value, then you will get the answer is 5 into number of 3. After that, we need to multiply. So this row into this column, minus 1 into 0 should become as 0, plus 0 into 0 become as 0, 1 into 0.04 become as 0.04, 0 into 0 become as 0. After that, we need to multiply the whole the value, then it will become as sigma 1 is equal to 200 Newton per mm square. After getting the same procedure we need to follow for the element number 2, element number 3, element number 4, we need to follow the same concept. Clear? Sigma 2 is equal to E2 by L2 minus L minus M, L, M. So because Q3, Q4, Q5, Q6 is there. So Q3, Q4, what we can set here, already I told you. So in this case, node 2, okay, and Q5. So here just small mistake, instead of Q3 and Q4 you have to go for node 2, not node 1, node 2. Please make the correction, node 2. Q5 and Q6 we can say as node number 3. Modulus of elasticity is how much is there? 2 into number 5. The length of the element is how much is there? 30. So L and M we need to take from the table. So L value is how much is there? 0, and M value is how much is there? 1. Clear? L we need to substitute here. L value is 0, M value is minus 1. L value is 0, M value is 1. And Q3, how much we got here? 0.04 in 0, and Q5 value is 0.00822, and Q6 value we got. We solved the equation. So for that reason we get the value of Q5 and Q6. Q5 value we got, yes, we got the 0.00822, and Q6 is minus 0.322277. After that, if you divide this value, then it become as 6.67 into number 3. Just you need to multiply this term. 0 into 0.04 it become as 0, minus 1 into 0 it become as minus 0, plus 0 into 0.00822 become as again 0, plus 1 into minus 0.03277 it become as minus 0.3277. After that, if you multiply this value, it become as minus 218.47 Newton per mm square. The same procedure we need to follow for the element number 3. So element number 3, sigma 3 is equal to E by L3 minus L minus M, L, M. And this is Q5, Q6. This Q5, Q6, what we can say, already I told you, node 3. And Q1 and Q2, what we can say, node 1. The same concept we need to follow here. And E is how much is there? Modulus of elasticity is given as 2 into 10 power of 5. And the length of the element is getting the 50. And minus L is minus 0.8. M is minus into minus should become as plus 0.6, minus 0.8. L value, M value is minus 0.6. Clear? Q5, Q6 already we got, Q1, Q2 value is 0. Clear? After that, just you need to multiply this value. If you divide this value, then you will get 4 into 10 power of 3. 0.8 into 0.0822 then it become as 6.576, 0.6 into 0.3277 plus minus 0.8 into 0, which become as 0, minus 0.6 into 0 become as 0. After that you need to multiply this value, then you will get the answer is minus 52.4 Newton per mm square. After getting the value of sigma 3, again we need to find out the for element number 4. Sigma 4 is equal to E by L4 minus L minus M L and M, Q5, Q6 and Q7 and Q8. So already I told you Q5, Q6 what we can say node number 3, and Q7, Q8 already we know very well, this we can say as node number 4. So just you need to substitute the value of Q5, Q6, Q7 and Q8. After that if you divide this value 2 into 10 power 5 by 40, then it become as 5 into 10 power 3. Clear? After that you need to multiply this value 1 into 0.00822 plus 0. This whole the value become as 0, minus 1 into 0 it become as 0, 0 into 0 it become as 0. Clear? After that if you multiply this value 5 into the power 3 into 0.00822, then you will get the answer is 41.1 Newton per mm square. In the step number 8 we need to determine, because we got the value of sigma 1, sigma 2, sigma 3 and sigma 4. After that we need to find out the value of R1, R2, R3, R4, R5, R6, R7 we need to find out. Clear? Then we know very well, let us see this figure, because if it is the hinge support, for that reason which reactions will acting, the normal reaction R1 is acting at this point in a horizontal direction, as well as the normal reaction R2 is acting in the vertical direction. Clear? If it is a roller support will be there, only vertical force is acting. Which force? Only vertical normal reaction is acting in a upward directions. Clear? Here the some amount of horizontal force is acting toward the right side. For that reason the normal reaction R3 is acting. It become as 0. Again here R5 value it become as 0 and R6 also 0. Clear? Because it is a pin hinged. Again here support is there. For that reason horizontal force as well as the vertical force is acting R7 as well as R8. After that what we need to find out, our main intention is we need to find out the value of R1, R2, R3, R4, R5, R6, R7, R8 we need to find out. Clear? The same formula, the normal reaction R equal to global stiffness matrix and the nodal displacement minus nodal force. Clear? The same matrix, above matrix K value you have to draw here. After that the nodal displacement is Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8 value you need to substitute the value, minus the nodal force is how much? F1, F2, F3, F4, F5, F6, F7 and F8. Clear? After that just you need to multiply this first, this is 5 plus 2.56 nothing but 7.56. 7.56 into 0 it become as 0. Clear? Again 1.92 into 0 it become as 0, minus 5 into 0 it become as 0, minus 2.56 into 0 it become as 0, minus 1.92 multiplied by 0 become as 0. Again 0 into 0 0, 0 into 0 again 0. Over. This first is completed. Come to this point, 1.92 into second one, this second one, 1.92 into 0 it become as again 0. The whole the value will become as 0, because if you multiply with 0 this value, all the value become as 0. Clear? Come to this point of this third column, and this we need to multiply with third row, minus 5 into 0.04. Okay, minus 5 into 0.04 it become as minus 0.2. 0 into 0.04 it become as 0 only. 5 into 0.04 it become as 0.2. Clear? Again this 0 into anything should be how much? It should be 0 only. Clear? Come to the fourth one. Okay, fourth 0 into fourth row all are become as 0 only. Come to fifth one, fifth row. So in the fifth row minus 2.56 into fifth one is 0.00822. If you multiply then it become as minus 0.021. Again minus 1.92 into 0.00822 it become as minus 0.157. Again, if you multiply 0 into 0.00822, it becomes as 0. If you multiply this value 0 into 0.0822, it becomes as again 0. Again, this 7.56, if you multiply with 0.0822, it becomes as 0.062. Again, if you multiply 1.92 into this value, it becomes as this one, 0.0157. Again, if you multiply with 5 into which one, 0.00822, become as minus 0.04 whatever one. If you multiply with 0 into 0.00822, it become as 0. Clear? After that, this row into this column into this row, minus 1.92 into this row's value as how much is there, minus 1.92 into minus 0.03277, it becomes as 0.0629. Minus 1.44 into minus 0.03277, it becomes as 0.047. 0 into minus 0.03277, it becomes as 0. Minus 6.66 into minus 0.03277, it becomes as 0. 1.92 into minus 0.03227, it becomes as minus 0.062. Again, same procedure you have to follow here. Again, this value 0 into 0, it become as this all column become as 0, and this all column become as 0. Again is minus 0 0 20 into 10 power 3, 0 0 minus 25 into 10 power 3, 0 0 as it is, keep as it is. After that, remember one point, we need to add this all the value 0 plus 0 plus minus 0.2 minus 0.021 plus 0.629, then you will become minus 0.1581. If you add this whole the row, it become as 0.0313. If you add this whole the value, it become as 0.2. If you add this fourth row, it become as 0.29. If you add the fifth row, it become as how much? Fifth row is become as 0. If you add this sixth row, it become as minus 0.25. If you add this seventh row, it become as minus 0.041. If you add this 8th row, it become as 0. This matrix as it is. After that, again we need to subtract this value, minus 0.1581 minus 0 above value. Clear? Minus 0.0313 minus 0 here. 0.2 minus 20 into 10 power 3. Clear? Again 0.218 minus 0. Clear? 0 minus 0 here. In R6, minus 0.25 minus into minus plus 25 into 10 power 3. Then you will get some answer. Minus 0.0411 minus of 0. Okay? After that, if you calculate this value, it becomes as like this. If you multiply 0.1581 into 10 power 5, then it becomes as minus 15810. If you multiply this value, it becomes as 3130. If you are subtract this value, it becomes as 0. So if you multiply this value, then it becomes as 21800. So if you subtract the value, it becomes as 0. So if you calculate this value, it becomes as 0. So like this, 4111 we got it. So we understood that the R1 value, this R1 value is minus 15810, R2 value is 31330, R3 value is 0, R4 value is 21800, R5 value is 0, R6 value is 0, R7 value is 4110, and R8 value is 0. So after that, we need to represent this result. The result is most important here. Based on the result only, you will get 100% marks. So the nodal displacement we got as Q1, Q2, Q3 and Q4, Q5, Q6 and Q7 and Q8 already we have find, and the normal reaction already we have find, and we have to present the elemental stiffness matrix sigma 1, sigma 2, sigma 3 and sigma 4 we have to represent. I hope so no one is having the doubt regarding this class. If you have the doubt regarding this class, please write down in the comment box, and please don't forget to subscribe my channel. Okay dear, thank you.